All right, so for the rewind for number 1, what did you have to do? Diego? Plug in the values they gave you, right? So they plug in the values they gave you. How is number 2 different than number 1? They didn't give you a domain. So what do you have to do if they don't give you a domain? Make your own domain. What was my advice on what you should do when you make your own domain? Yeah, something like -2, -1, 0, 1, 2. What did I say overall you should not use? Don't use huge numbers. It makes it harder for yourself, right? But I did say you should always include what? A couple negatives and then 0, okay? Because as you can see with the absolute value one and the exponential one that you just did, this first graph ended up looking kind of like a what? Like a check mark, like a V, right? And then this second one ended up looking like a what? A hill, like an upside down hill. All right, so it's a parabola, right? We talked about parabolas. So if you don't do the negatives, if you only do the positives, you might miss that. Like for example, if you'd only done the positives here for this first one, you might have ended up with 0, -1, 1, 0, 2, 1, and 3, 2. And you might have ended up thinking this was what? Just a line, right? Like it looks like a line with a slope that we've seen before. And that would not be right because the -1 went like this. So you end up with this as your graph, where if you didn't do the negatives, you wouldn't have seen that. Okay, so that's why I harp on including a couple negatives. I know that the math becomes a little bit more difficult when you include the negatives, but it's worth it because otherwise you might not see the whole picture of what the graph is. Just as a reminder to you guys, an absolute value graph is always going to look something like this, where it's like a V, all right? And an exponential graph is always going to look like a what? Like a hill, like a parabola. Okay, so like a U, all right? And that's exponential means that it has a what? Exponent. So when you see a squared like this, you know that it should be a parabola. So if yours looks like a line, if it's an exponential function, you've probably done something wrong, so you want to check yourself. And I would say 9 times out of 10, the mistakes are probably where? In the positives or negatives? Probably in the negatives. And that's not because... It's not because you're bad at them, right? It's just people get careless with their negatives. And if you forget a negative sign, it changes everything, okay? So it's not necessarily, it's just like you start doing things too quickly and you get a little bit careless. Okay, so we're going to talk today about a type of graph called a scatter plot. What is a scatter plot? There's dots everywhere, right? Are they always all over the place? Or do they sometimes make sense? What do I mean when I say they make sense? Go ahead, Brendan. They show a relationship, right? So this scatter plot right here that's on the screen right now, does this make sense? Yeah, it shows growth, right? It shows growth going upwards, which means over the course of several days, what's happening here? More CDs are being sold over the course of several days, right? This is obviously a very old graph because I don't think any CDs are being sold at this point, right? But in 1997 or whatever this book was made, there were CDs being sold. And as the days went on, more CDs were sold. Why does that make sense to you guys? Why would that be true? Why would there be more CDs sold as the days go on?
Because it's more of a range of days, so people would ask to buy more.
Yeah, people are coming in to buy more CDs, right? If on day 1 you sold 10 CDs, the second day, even if you only sold a couple, your overall number of CDs sold went up, right? Okay, so a scatter plot like this has what we call a correlation, and that's what we're going to talk about today, what it means to have a correlation and 3 different types of correlations. And again, it shows a possible relationship between 2 sets of data. In this graph right now, our 2 sets of data are the days and the numbers of CDs sold. So we organize that by our x-axis and our y-axis, okay? So how do you make a scatter plot then? How would you graph this scatter plot from the data that's given? All I'm giving you is a blank sheet of what looks like a coordinate plane and then some data. All right, and it says the table shows the number of species added to the list of endangered and threatened species in the United States during the given years. Graph a scatter plot using the given data. So what would you have to do first? Rodrigo? You'd have to what? Yeah, put the years either on the bottom or the left. Typically, that first one is going to go where? Typically, like this one right here would go on the x-axis because this is your domain. All right, so this is our domain, so I'm going to label it. Say calendar year. And then that means I'm going to label this what? All right, so species. Where do all graphs start? At 0. They all start here at 0, 0. This is always the point 0, 0, which means it's been 0 years and 0 species. So then what do I want to put on my calendar years? Where do I want to start that? 1996. I don't want to start it with 1. Why not?
Because the year starts at 19.
Yeah, the first year that I have on here is 1996. So does anyone know what you do with a graph when you want to go from 0 and jump to another number? Brendan? Yeah, you do a squiggly thing, right? So we're going to squiggle it. All right, and then we're going to say this is 96. Then what's this one? 97, and so on. And we have to go all the way up to what? And I'll keep going all the way to 06, just because I like to finish that out. Okay, all right. Now my number of species. How am I going to label this graph? Or I guess how am I going to label this axis, the y-axis? What number should I start with? 10, 20. Why 10, Diego?
Because it goes like 10, 20, 30, 40, 50, 60, 70.
Why don't I want to count by ones? There's not enough spaces, and it's so little. I would have to make, because this goes all the way up to 91, I would have to make a really, really tall graph if I wanted to count by ones. So I don't want to count by ones. I think it makes sense to count by tens. So we'll go 10, 20, 30, 40, 50, 60, 70, 80. And what am I going to have to do? I'm going to have to add a little bit up here. So that's fine. So I can add a 90 up there. And I technically would probably have to go all the way up to 100. Okay. How come I don't need a squiggle line there? There are numbers, okay. Yeah, there's numbers between 0 and 10, but how come I don't have to put that little squiggly line?
It's kind of like common.
What do you mean?
Like it's already known that numbers will fall between 0 and
Okay,
10.
so I'm counting by the same thing right here, right? But on the bottom axis, on this x-axis, I want to count by ones, but I don't want to count by ones starting from the very beginning all the way to 96. I want to skip some. So this right here, this squiggly line, indicates that I've skipped some. Okay, so can I get a couple volunteers to come up and plot this for me? I need 7. Brendan, Diego, George, Brayland. Ladies. Just start from the first point, George, and then go from there. Good. That was rude. Oh, I have it. Gentlemen. Okay, thanks, Brendan. Looks good to me. Can I get 3 more people to come up and finish it? Alejandra? Two more. Just one more, actually. One more person. Ashley? Good. I think we skipped a year. I think we skipped 1998, so I'm just going to put that on there. Okay. And I'm just going to make them a little bigger so that you can see where everybody's plots are. All right, so in this scatter plot, is there a relationship between the calendar year and the number of species increased? No, there's not. Why not? Okay, it rises, falls. It's all over the place, right? It's unsteady. So if I asked you to predict what would happen in 2003, could you make a prediction? Yeah. Yes, but would it be very reliable given the past data? No, because, for example, from 1999, the species added to the list was 11, right? And then it shot up in 2000. So you can't say necessarily that there's a correlation between those two sets of data. All right, so when we talk about correlations, we either talk about a positive correlation, a negative correlation, or no correlation. And positive correlation means what? What's happening in a positive correlation? Montreal? What goes up? The data, which one? X or Y or both? Uh-huh. So is the X, the Y, the X going up, the Y going up, or are both of them going up? Both of them are going up. As you move along the x-axis going up, which is to the right, your y-axis moves up. So it ends up making a positive correlation, which looks like a slope is positive. All right? Here in a negative, as your x goes up, what happens to your y? It goes down. So that's called a negative correlation. And if you were to draw a line in there, it would be sloping downward. Does anyone know what that line is called? Yes. All right. Does anyone know what a line is called when you draw a line through a scatter plot?
I remember what it
Starts with a T. It's a trend line. It's a trend line. When something, and because, why do you think they call it a trend line?
Because it's like an estimate of what it would be.
Okay. All right. Why trend though? Yeah, like that's what's happening, right? That's all the data is clustered around that line. So even if these points, even if we don't connect the points, which we don't in a scatter plot, if you put a trend line, it should go kind of through the middle because all the data wants to cluster along that trend line. Is there a trend line if there's no correlation? No, because the data is just all over the map, right? The data is all over the place. There's no correlation between the X and the Y, so we could not put a trend line even if we wanted to. All right, so describe the correlation illustrated by this scatter plot. This would be a negative correlation. Good. Which means that as the number of hours of TV that you watch go up, what happens to your test score? It goes down. So one is going up while the other is going down, which is probably pretty accurate, right? Like if you have a test and you spend 6 hours the night before watching TV, your test score is probably going to go down. Why is that? You didn't study. Not only did you not study, you also probably didn't do what? Sleep very much. You probably didn't do your homework, all right? Because if you watch 6 hours of TV one night, you're probably watching it 6 hours of TV most nights. Okay, so at your boards, I want you to try to identify the correlation that you would expect between the first two, and then in number 7, I want you to do the same thing. So objectively try to determine the correlation. Okay, so then how do we match scatter plots to situations? So we talked last week, and you guys had this on your quiz, matching situations to continuous and discrete graphs. But what we're going to talk about today is matching scatter plots to situations, so essentially combining the things that you just did. So being able to say what's the correlation between those two sets of data, and then what would that scatter plot look like. So in this first example, it says choose the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. So before you even look at those graphs, tell me what you would assume would be the correlation between those two pieces of data. So again, the number of days since the sunflower seed was planted and the height of the plant. Alejandro, what are you thinking? Why? Yeah, it grows. It grows and grows and grows. All right? So which one of those graphs do you think would be the best representation? All right, so graph C, because on day 0, the plant had not grown at all. As it went up in days, what happened to the plant? It got taller and taller. Do you think this would be the end of the graph? What should probably happen to this graph if you kept going for more and more days? It would start to go down. Matthew, why? Because the plant dies, right? And as the sunflower dies, it starts getting shorter and shorter because it droops over, and then all of a sudden it's dead and gone, right? So it would ultimately go back down to 0. How do you know that it cannot be graph B?
Because it's just not.
It's on a coordinate plane. Montrell? It's negative. Can your sunflower ever be negative 20 inches tall? No. All right, so you can't have a negative height, nor can you go back in time and plant it negative 20 days ago, right? Maybe you can, and if you can, more power to you. All right? What about this first graph? What's wrong with that first graph? It starts off right at 60, and it told you that you were planting a what? A seed. I've never seen a seed that's bigger than the actual plant that it makes, right? So when you're looking at these scatter plots, the best thing to do first is figure out what you think the correlation is going to be, and then match the one that looks most like that. Okay, so for this practice, I know these are really, really tiny, so if you can't read these on your slides, which I assume that you cannot, I'm going to read them for you right here, and then you guys... Actually, we'll just answer these at our seats rather than y'all going back up to the board for this. So this first practice says there's a negative correlation between the number of hours a student watches television and his or her social studies test score. Which scatter plot best displays this correlation? So on your slides, write down which scatter plot best displays this correlation. I'm going to read it one more time. There's a negative correlation between the number of hours a student watches television and his or her social studies test score. All right, so the first one is, this is number 1, this is number 2, number 3, and number 4. Okay, go ahead and hold up your answer, 1, 2, 3, or 4. 1, 2, 3, or 4. Show me with your hands what you think it is. Okay, so pretty much everybody I'm seeing is saying 4. Why 4? 4 is the only one that has a negative correlation, right? What about number 2? Number 2 is what kind of correlation? Number 2 is a positive correlation. Number 3 is what? That's scattered, no correlation. What about number 1? It's a constant. So what type of line would be the trend line there? Horizontal. It would be like a horizontal line. Okay. Number 2 says, which scatter plot shows the relationship between x and y if x represents a student score on a test and y represents the number of incorrect answers? Okay, so again, x represents the student's score, and y represents the number of incorrect answers. All right, hold up what you think it would be. 1, 2, 3, or 4. Okay, so most people are saying 2. So in number 2, as the test scores get higher, what happens to the number of incorrect answers? It gets lower, right? Because if you get a good test score, that means you probably didn't get very many questions wrong. All right, so that would be what kind of correlation? That would be a negative correlation. Good. Okay, so go ahead and